So this is Qt for WebAssembly. My name is Morten Sørvig. I'm a software engineer at the Oslo office. So welcome. Oh, thank you. So Qt for WebAssembly. What can we do? Oops, and I see we have technical problems already. But, so let me reload my presentation. Like so. So Qt for WebAssembly allows us to now run Qt applications and Qt examples in the web browser. So these are all interactive Qt-based examples. So I can click and drag here, type into the thing here. Oops, let's see. Qt World Summit. So in this talk, I'll explain a little bit about how this works, how you can use it. So I'll talk about a little bit about what WebAssembly is, and also about MScript, which we are using. I'll show you how to build Qt for WebAssembly and how to build your applications. And then I'll talk about some topics regarding integrating with the web platform, and also how your applications can work with the web sandbox. Yeah. But first, that's kind of perhaps the first question is why use Qt for WebAssembly? So this is, we are kind of borrowing some of the benefits that web applications have, such that you can build once and then deploy to everywhere, or perhaps to all web browsers that support WebAssembly. Another benefit is that there is no kind of installation step required. So like web pages, the applications can run immediately once they are uploaded. So there's also no kind of app store validation or certification process. And finally, there's a sandbox. So users don't have to trust Qt or trust your applications. They are sandboxed and are not able to access the system. So the platform stack looks something like this. You have a Qt application or an application that's using Qt. We are using MScript as an SDK. And then finally, this builds on the HTML and WebAssembly support in the browsers. So WebAssembly. So WebAssembly, that's the web standard. It's a standard that defines a binary instruction format where the browsers implement an engine that can run applications distributed in that format. And so WebAssembly is implemented in the major browser engines. So it has become kind of well supported. MScript, that's the toolchain we're using, the SDK. So MScript provides an LLVM-based compiler, a C++ compiler, which we use to build Qt and the application. And it also provides some runtime support in the form of C++ APIs that wrap the native HTML APIs. So you can use browser features from C++ in the same way that you can use JavaScript if you're using JavaScript. Okay, so on to Qt. So that's a new platform for 5.12. It's in tech preview. There are So when using it, you need to be on a supported host system. And we support, for now, we support the kind of the Unix systems, so macOS or Linux. Or you can also use the Windows subsystem for Windows, which you can install on Windows. So that's the host system support for compiling and building your application. So for 5.12, we don't have binaries yet. So this is a shipping, or you are going to have to build Qt from source code. So I'm going to talk a little bit about that. So if you've built Qt from source before, then this should be familiar to you. If not, then it's pretty easy to get started. So you start by downloading the sources. So there's a checkbox in the online installer you can use. And at this point, you want to select the Qt final release, not the beta. So after you've downloaded, you can you build Qt from source. And the first thing there is then to run the configure script. And you specify that you are cross-compiling for this target, WebAssembly and MScript. And then you also pass no-make examples, because we are not going to build all of those. And this is going to be a static Qt build. And also at this point, threading is disabled. So depending on how your application is structured, there might be some porting work for you there. We support several modules: Qt base, where widgets are, and also the kind of Qt QE and the base of Qt. Qt declarative, which contains Qt quick. And then the Qt quick controls 2 works, and also charts and some other modules like WebSockets for networking, and also Qt MQTT. Multimedia is not supported at this point, and Qt Web Engine isn't going to be supported at all. So, yeah. There is some more fine print. Like we don't have system clipboard integration at this point. Another big important thing is that we don't have access to the system fonts. So in this regard, the Qt application will be more like an embedded application where you have to kind of embed the fonts you need. So that's kind of an important thing to be aware of. If you go to the wiki, there's a link here. If you go to the wiki, we have a platform notes page where we list everything in detail, and we try to keep that one up to date as we discover various limitations and we also keep that up to date when these things are fixed. Okay, so we have built Qt, and now we're going to build the application. And so we support QMake as a build system for now. So if you've done that before, that's pretty straightforward on the command line. And the output from this will be the .wasm file that contains the application binary, and also a couple of JavaScript and HTML helper files that kind of provides the environment and the loader for the application. And so these are plain data files, and you can put them on a web server. And there's no specific requirements really for the web server. It can be any web server. And then when the user visits, the application will be running on in the user's web browser. Some more details about the files, So this is where all of the application code goes. MScript will provide a runtime, and then Qt, we have a loader. where we have an API for loading Qt applications, and also there's a container HTML file. File sizes are interesting when distributing over the web. So I went ahead and measured a couple of examples. And so the file size depends, of course, of how big the application is and how much you're using, how many of the Qt modules you're using. And we recommend that you compress the files when serving them. So many web servers support compression on the fly. There are two different standards you can use, or compressor implementations. gzip is well supported and compresses pretty well. Brotli compresses a bit better. So if you really want to minimize bandwidth usage, then that's the one to use. I also looked a bit at memory usage, which is also interesting. So I compared a Qt-based application. It's called Slate, and we'll take a look at that one later on. And I compared that one to one of the WebAssembly demos, the Tanks game, which you might have seen, and then to a complex web page and a simple web page. And then finally to the native version of the app, just compiled for macOS. So there is some memory overhead. I haven't dug any deeper into this, so yeah. But we are kind of on the same level as other WebAssembly applications, or yes, or other WebAssembly applications, or kind of on the same level as a complex web page. So okay, so the way that the Qt application is integrated with with the HTML page is that the Qt GUI, the application GUI, will be rendered to a canvas element. So that's an HTML element. And that's going to be a WebGL-based canvas. And then the HTML page can control the canvas position and size. So it can occupy the entire viewport, or it can occupy a kind of a smaller rectangle in the page. And then on the Qt side, this canvas becomes a Q screen, and then the application can place windows on that screen. So you can make them full screen, to use the entire canvas area, or you can make them windowed. Then you get window decorations from Qt. So let's look at a demo. We're going to look at Slate, which is an image editor, or a pixel art editor, made by a colleague of mine, Mitch. And here it is in the browser. So I can, let's see, I can draw like so. Let's go for the abstract art. So this is kind of the application occupies this rectangle in the page. You can look at a full viewport example. So in this case, it will resize with the browser, like so. Now resize Firefox. We also support web page zoom, so I can scale in and out if I want to. So the UI is scalable. And this is the same as high DPI support, so that also works. We can try some different browsers. Let's see. This is Safari, and this is the loading screen. Google Chrome. There we are. So loading performance varies. Firefox is really fast. Safari is still going. Firefox has been really fast. I mean, it's like, 1 or 2 seconds. But once it's loaded, then all of these perform okay. They are all usable. And, yeah, I think that's what I wanted to show for loading. Let's see if I can get back to 100%, and then yes. Time. Yeah. Okay. So local file access. So there is a sandbox, but QFile actually works. You can open a file, but it's going to be to an in-memory file system, which is provided by MScript. So depending on what you do, I mean, yes, you can use QFile to save a temporary file, for example. So that eases porting a bit, perhaps. If you want to open a file on the system, then you have to ask the user. There is HTML API for that. Unfortunately, that API is not compatible with QFile the QFile API. So what we are going to do, we are going to provide a helper API for WebAssembly, and it's going to look something like this. So there's going to be a load file function, which you call, and you specify which file types you're interested in. And then you get a callback, or you provide a callback, where you get the file content and the file name. So you don't get to open the file yourself, you just kind of provided the file content that the user has selected. So what this function will do is that it will open it will ask the browser to show a file dialog where the user will select the file they want to open. Similar API for saving a file. So that's kind of this API will start a download. And so the user can specify where he or she wants to save the file. So you provide the content, and then a kind of a file name hint what the file should be named. So let's see. And I've implemented this in my demo, so I can draw again. File save, and this is a native dialog opened by the browser. I'll save file, yeah. And then if I open, then I can select that file, and this is also a native dialog, one other file. And there it is. So round-tripping data to the local system is possible. It's just not as convenient as in the native applications. So networking is, it's also sandboxed, but it is possible. We have been looking at 3 different options. So one of them is to make HTTP requests, which you can do. Those are allowed by the sandbox, either back to the origin host, or the host where that application was served from, or to a host that supports cross-origin resource sharing. So that means that web servers can set headers to indicate that it's OK to make requests for certain resources from a different origin. So yeah. So this is well documented in the web world, so you can look it up, but it's something to be aware of. WebSockets work great on the web, so you can make WebSocket connections to any host using the QWebSocket API. There's also a third option. I haven't tested this one myself, but MScript suggests using something called WebSockify to tunnel TCP connections over WebSockets via a server that is running WebSockify, which will then forward to the final destination. So if you have an application that is based on TCP sockets, or if your application is using TCP sockets, then this might be an option for you. Let's see for time. Yeah. So I have an example here. This is our MQTT example. So MQTT is, if you're not aware of it, it's a kind of a publish-subscribe messaging system. We have a Qt module for it. And that module works on WebAssembly. And you can then communicate or connect to a broker host that supports WebSockets. And I'd like to bring up the, let's see, the debugger here, or the network debugger. Just to show you how that can work. Let's see, network, yeah. So if I hit connect here, we should see the connection being made down in the debugger. So let's see if you're looking. Yeah, there it was. We can then use the built-in debugging features of Firefox in this case to look at header and so on. You can see that, yes, this is a WebSocket upgrade request. Let's see, I can subscribe and then publish a message. Yep. So what happens if you quit an application on the web? That's an interesting question. So then you get this. You go back to the loading screen, and you can see that, OK, this was an application exit with code 0. So quit buttons might not make sense on the web, so you could remove those from your UI. Let's see. Oops. Yeah. OK, final topic. And I think we just have time. Yeah. So sometimes the web or the Qt application will be the entire content on the page, but sometimes you want to mix HTML and Qt content. And that's possible. MScript helps us here and provides API for exporting functions from the C++ side and then calling them from the JavaScript side, and the other way around. So here I have one example. So these images are drawn by the browser. And then this color debugger thing here is a Qt-based component. So I have a mouse over event listener on the images that will read the pixel RGB value at the point, and then call into Qt and provide that value. And then Qt can update its display. So let's see. Oops. Yeah, Qt is stealing the keystrokes here, but luckily I have a button. So yeah. And just to show you how this works, in this example I have a specific C++ function, setColor, and I use this MScript macro to export it. And I can then call it from the JavaScript side. So it's exported on this global module object, and I can call it like this. So that's actually pretty simple. And I think that was, yes, that was it for me. So I think we have, thank you. If there are questions.
Thank you, Morten.
Thank you.
We are testing our application in WebAssembly, and it's fantastic. Everything is fantastic, except two minor things. We are using QDialogs with the sec and blocking sockets. And the question is, do you bear in mind how or when we could use them?
I didn't get, what are you using? I'm sorry.
In our application, blocking sockets, Qt blocking sockets.
Okay, blocking.
Blocking sockets, yeah.
Okay.
With the others, there is not any problem at all.
Okay.
But blocking sockets, and when we launch a QDialog, we use a sec, and,
Okay, yeah.
and the application is frozen.
Yeah.
And the question is, do you have any idea when or how achieve it?
I'm not sure. I think we are going to make some improvements for 5.13, so, but I can't promise anything specific. Yeah. So please just watch what you're doing and then see if it works for you.
Okay.
Yep.
Thank you.
Is there a Qt interface to local persistent data like cookies or IndexedDB?
IndexedDB. No, we don't have any Qt API for that, I think. Yeah. So in general, MScript has a lot of API for accessing HTML features. So that's kind of the first place to look, I think.
Hi.
Hi.
Does it also work for plain old widget applications?
Yes, widgets should work. Yeah. So.
Hi.
Hi.
I think in the beginning you mentioned that the Q event loop is not supported, and how exactly the user interaction events then working?
Yeah, so the event loop is supported. It's just nesting the event loop is not supported. So some dialogues you call dialog exec. That kind of works, but not fully supported. So.
But threading in general works?
Not yet. That's 5.13,
okay.
I think.
So it's one thread, and for this one thread, the event loop exists still?
Yes, yeah.
Okay,
yeah.
Thank you.
How do you work with QML? Do you have to recompile everything all over again after you edit one QML, or?
Yes, it depends. I mean, you can load QML at runtime. It depends on how the application is structured, but
you know, in a normal application, you would just edit the QML, start again the application, and you don't have to recompile all over again. So is it like the same setup, or you just get the JavaScript files, or alongside you get QML files, or do you get only one JavaScript file in the end?
It should be possible to do both. It should be possible that you just put the QML files on the server and then load them at runtime, in which case you don't have to recompile. I haven't tested that use case very much. I have my QML are in resources, Qt resources. And if you do that, then you need to recompile, of course. But yes, but that use case is something you want to support. Yeah.
Last question there, and then we'll set for recess.
Yeah.
What's the timeline for Qt3D for WebAssembly?
So Qt3D needs threads, I think, and that's 5.13. So I'm going to take a look at it for 5.13. I can't promise anything, but that's the earliest, at least.
Mm.
Yeah.
So also like things like FBX importing and stuff like that.
I'm sorry, what was the final day?
So importing FBX files, for example, for doing 3D animations, importing. Is this also on the roadmap?
I don't know anything about how that works. So, but that's a Qt3D feature, or
yes.
Yeah. So I don't know. It should work as it does on desktop, I would say.
All right, thanks.